Watching channel Maths and Methods Academy. In this video we are going to learn how to find HCF of the given algebraic expression by factorization method. The expressions given in this question are x squared plus 5x plus 6. This is the first expression, and the second one is x squared minus 4x minus 12. Please remember to subscribe the channel, and now we proceed with the solution. We assume that first expression is equal to px and the second one is equal to qx. Now we will factorize both the expressions one by one. Let's go with the first one first. This is a quadratic expression, or we can say an expression of degree 2. We will apply our same method which we have been usually applying for making factors. Since x square is not having any coefficient, it means it is 1. So we will multiply this 1 with this 6 and we get 6. Now we will make all the possible pair of factors for 6. Of course, first will be the same, which is 1 into 6 is equal to 6, and the second one is 2 into 3 is equal to 6. Now which one of these two pair of factors, when we add or subtract, gives us plus 5x? This one. Obviously that is this second one. So instead of 5x we can write 3x plus 2x in the expression. So we will be replacing in the expression this 5x with 3x plus 2x. X squared plus 3x plus 2x plus 6 . Now we will make here pairs. So in the first pair, that is x squared plus 3x, we have x common, and in the second pair we have 2 common. So again we have in bracket x plus 3. Now x plus 3 is common and we are left with x plus 2. In this way we have factorized our first expression, which is px. Now we go toward the second one, which is qx. Qx is equal to x squared minus 4x minus 12. We will apply the same method as we have applied in case of first expression. So x squared is not having any coefficient, which means it is 1. We will multiply it with 12. 1 into 12 is equal to 12. So we will be making all the possible pair of factors of 12. First one is the same. 1 into 12 is equal to 12. Then 2 into 6 is equal to 12. Then 3 into 4 is equal to 12. So we have these three pair of factors. Now we have to check which one of these two, when we add or subtract, give us minus 4. Obviously the second one, this one. So what we can do, we can substitute minus 4x with minus 6x plus 2x. So we will replace minus 4x with minus 6x plus 2x minus 12. Now again we will make pair of terms. In the first two terms x is common, and in the second two terms 2 is common. Now in both the terms we have x minus 6 common, and in the second bracket we are left with x plus 2. So in this way we have factorized our second expression as well. Now we have to see which factors are common in px and qx. Obviously there is only one factor, which is x plus 2 and x plus 2, which is common in both the expressions, and this common factor will be actually of our highest common factor. So x plus 2 is our answer in this case. We move towards our second question. Our second question has actually three expressions, which are x cube minus 27, x squared plus 6x minus 27, and the third one is 2 x squared minus 18 . 2x squared minus 18. Again we are going to factorize all these expressions one by one. First of all we will give them a name. So let px is equal to x cube minus 27, qx is equal to x squared plus 6x minus 27, and rx is equal to 2x squared minus 18. Okay, now we will take our first expression, which is px is equal to x cube minus 27. It is very obvious in this expression that both the terms are cubes, like x cubed, and the second one is 3 cubed. So we can write them like x raised to power 3 and 3 raised to power 3. Now we have a formula which I think you can recall here. That formula is a cube minus b cube. Let us write it on the side so that we could remove it later. It is this one. A cubed minus b cubed is equal to a minus b into a squared plus ab plus b squared. Now using the same formula we will write here x minus 3, then we will write x squared, then we will multiply 3 and x, and then square of 3. So you can see on this principle we have written two factors here, like x minus 3 and x squared plus 3x plus 9. Now we move on to our second expression. Qx is equal to x squared plus 6x minus 27. Again, this one is a quadratic expression, so we will factorize it in the same way as we have always been doing. X square has no coefficient here, which means it is 1. We multiply 1 with 27 and the answer is 27. Now we will make all the pair of factors for 27. The first one is same, 1 into 27 is equal to 27. Second one, 3 into 9 is equal to 27. Is there any other pair of factor? 3 into 9. No, that's it. There are only two. Now we have to check which one of these two can give us 6 if its factors are added or subtracted. Obviously the second one, because if we subtract 3 from 9 we are getting 6. Okay, so 6x can be replaced with 9x minus 3x. And this 9 this one, 3 this one. So 9x minus 3x. Let's remove our rough work. Okay, now we will replace this 6x with 9x minus 3x. Delete this one. Now in the first pair, this is the first pair and this is the second pair. In the first pair we have x common, so in the bracket it is x plus 9. In the second pair we have minus 3 common, so again inside bracket x plus 9. Now x plus 9 is common in both the expressions and the second bracket is in this case x minus 3. So we have factorized our expression. Now we move on to our third expression. So Rx is equal to 2x squared minus 18. We have only two terms in this case, in this expression. First of all, we will take 2 common. So we will be left with x squared minus 9. Now x squared minus 9, these two terms both are square, and you know we have a formula. First of all, let us write it like this: 2 into x squared minus 3 squared. So since there is a difference of 2 squares, so for that there is a formula which is a square minus b square is equal to a plus b into a minus b. Using this formula we can write 2 into x plus 3 into x minus 3. In this way we have factorized all our three expressions. Now let's see which factor is the common one, highest common factor. X plus 3 is there in the first expression, x minus 3, then x minus 3 is there in the second expression, and x minus 3 is there in the third expression as well. So that is our highest common factor, and this is our answer. Now we move on to our third question. Again we have three expressions here: x cube, minus 2x squared plus x. Second one is x squared plus 2x minus 3. And the third one is x squared our second expression is x squared minus 2x squared. No, it's okay. First one is x cube minus 2x squared plus x. Second one is x squared plus 2x minus 3. And the third one is x squared plus 3x minus 4. Let us give some names to these expressions. So first one we call as px, second one qx, and the third one is rx. Now let's go on with the factorization of these three. We take the first one. You can see x is common in all the three terms, so we'll take x common. X squared minus 2x plus 1. In the bracket, we will factorize it as it is a quadratic expression. X square, since there is no coefficient, so it will be 1. So what we do here, we multiply 1 with 1. So what we have got 1. It means there is only one possibility, which is a pair of factors, which is 1 into 1 is equal to 1. Now we have to see if it satisfies that if we add these two or subtract these two, can we get the middle number, which is 2? Yes, we can. If we replace minus 2x with minus x and minus x, we are getting minus 2x. So we will write here x squared minus x plus 1. Now we will take common. In the first two terms x is common. In the second two terms minus 1 is common. So we have x into x minus 1. And again x minus 1. Now we move on to our second expression, which is qx is equal to x squared plus 2x minus 3. This is a quadratic expression, and let's factorize it in the same way as we have always been doing. 1 is the coefficient of x squared because there is no coefficient mentioned here. So we multiply 1 with 3 and we are getting 3. And in case of 3, this is the only possible pair of factors. So now we will see if we subtract or add these two factors, we can get 2x or not. Yes, if we subtract 1 from 3, we are getting 2. So 2x can be written as 3x minus x. So let us replace 2x with 3x minus x. Now in the first two terms x is common. In the second two terms minus 1 is common. Then in both the terms x plus 3 is common. In second bracket comes out to be x minus 1. So this is the factorization of our second expression. Now we move on to our third expression. Third expression is x squared plus 3x minus 4. Same quadratic expression, coefficient is 1. We multiply 1 with 4 and we get 4. Let's write all the possible factors, pair of factors. 1 into 4 is 4 and 2 into 2 is equal to 4. Now which pair of factors will give us 3 if both are added or subtracted? Obviously the first one, because if we subtract 4 from 1 we are getting 3. So what we will do here, we will replace 3x with 4x minus x. Okay, so x squared plus 4x minus x minus 4. X common in the first two terms, then x common in the minus x common in the second two terms. Sorry, minus 1 is common in the second two terms, so it is x plus 4 again. Now x plus 4 is common, and in the bracket we get x minus 1. Now we will look for the common factor in all the three, and here we can see that x minus 1 is there in the first expression, x minus 1 is there in the second expression, and x minus 1 is there in the third expression, which means our highest common factor in this case is x minus 1. So this is the answer of the third question. Now we move on to our fourth question. In fourth question we have two expressions. Number 1, 18 into x cubed minus 9x squared plus 8x, and the second one is 24 into x squared minus 3x plus 2. Let us give some name to the first. So let px is equal to the first expression and qx is equal to second expression. Let us factorize both of them now one by one. First one is px is equal to 18 into x cubed minus 9x squared plus 8x. We can see that x is common in all the three terms which are in the bracket, so we will take out x and we are left with x squared minus 9x plus 8 . Now we have again quadratic expression within the bracket, so let us factorize it. One is the coefficient of x square. We multiply 1 with 8 and we are getting again 8. So we will write all the possible pair of factors here. 1 into 8 is equal to 8. 2 into 4 is equal to 8. So these are the two possible pair of factors. Now we have to choose one out of these, which will give us 9 if we add those two factors or if we subtract those two factors. So obviously it is the first one, because if we add 8 and 1, it is giving us 9. So this minus 9x we can write as minus 8x minus x. So let us replace minus 9x with minus 8x minus x plus 8. Now we have x common in first two terms and we have minus 1 common in the second two terms. X minus 8 into x minus 1. Also we will make factors of 18. What will be the factors of 18? It will be 2 multiplied by 3 multiplied by 3. So that will be the factors of 18. Okay, this is our first expression. Now we move on to our second expression, which is 24 into x squared minus 3x plus 2. Here within the bracket there is no common like last time, but it is a quadratic expression and x squared is not having any coefficient, which means it is 1. Now we will multiply 1 with 2 and we are getting 2, and this is the only pair of factor possible in this case. Now we have to see if we add these two factors or subtract, can we get 3? Yes, we can get 3 if we add 2 and 1. So in this case I am talking about this 3 actually. So 2 plus 1 is equal to 3, but plus in the sense like minus we have to add. So minus 3x is equal to minus 2x minus x. We will replace minus 3x with minus 2x minus x. Now we have x common in the first two terms. We have minus 1 common in the next two terms. Now we have x minus 2 common in both the terms. Okay, now like the first expression, we will factorize this number as well, which is 24. So how we will get 24? We will be getting 2 into 3, 6, and 6 into 4. Wait, 24, 2 multiplied by 2 is 4, and then multiply by 2 is 8, and then multiply by 3, 24. So it will be 2 into 2 into 2 into 3. Okay, now we have both the expressions in front of us. This is the first one which we factorized. This is the second one which we have factorized. Now we will write our HCF. This time we have more than one factors common, so we will be choosing one by one. Let's go to the first one. This 2, we have 2 here, so we will write 2. Then in the next one we have 3 here and we have 3 here, so we will write 3. And now which one is common? I mean another one, yeah, x minus 1 is common in both. So these are the three factors common which we will take out, and we will write an HCF by multiplying all of them. So 2 into 3 is 6x minus 1, and this is the answer of this question. I hope I am able to explain it to you clearly. Now the last part of this question, we'll go to the fifth one. In fifth question we have only two expressions, so let's write those first. It is 36 into 3x raised to power 4 plus 5x squared minus 2x squared. Sorry, this is 3. Here 5x cubed minus 2x squared and the second one is 54 into 27 x raised to power 4 minus x. So these are the two expressions that we have, and we have to find out HCF of these two. Like the last four questions, we will give them some names. So let Px is equal to first one and Qx is equal to second expression. So let's start with our first expression. We will factorize it. Now here you can see that x square is common in all the three terms with the inside the bracket, so that we will take common. So we are left with 3x squared plus 5x minus 2. We have now quadratic expression within the bracket, so let us factorize it. This time x square has a coefficient which is other than 1. So what we will do, we will multiply 3 with 2. So 3 multiplied by 2 is equal to 6. Let us write all possible pair of factors for this. So that is 1 into 6 into 6 and 2 into 3 is equal to 6. Now which one we have to use here? Obviously the first one, because we need to have 5 plus 5. So plus 5 we can get only by subtracting x from 6. X from 6x. (36x squared) 3x squared. Instead of 5x we will write 6x minus x minus 2. In the first two terms 3x is common. In the second two terms we have minus 1 common. Plus 2 common in both the terms, and then 3x minus 1. Again here what we have to do, we have to factorize 36 also as a number, and x square we will also write as x multiplied by x. So what will be the factorization of 36? It is 2 into 2 into 3 into 3. 2 into 2 is 4, 4 3s are 12, and 12 3s are 36. And x we will also break down. and the other two factors will be written also. So this is the factorization of our first expression. Now we move on to our second expression, which is 54 into 27x4 minus x. Again we have x common in both the terms which are inside the bracket, so we will take it common, so it will, x is out, so we are left with 27x cube minus 1. Now you can see that both the terms inside the bracket, they are a complete cube, so we can write it like cube of 3x minus cube of 1. Now this is actually the form of a formula which is a cube minus b cube, can be written as a minus b into a squared plus ab plus b squared. Now using this formula we can write 54x into 3x minus 1 and then 3x into 1, so it will be 3x again. Sorry, first we have to write the square of 3x, which is 9x squared. Then we have to multiply these two, so 3x into 1 plus 3x and then square of 1, which will be 1. Okay, now again we will factorize the number also, which is 54. Its factorization will be 2 into 3 into 3 into 3, 2 into 3 6, 6 into 3 18, 18 into 3 54, and then x will be with it 3x minus 1 and 9x squared plus 3x plus 1. Now we have both the expressions. This is the first one px and this is the second one qx, and now we will write our HCF by choosing the common factors of both of these. Okay, the first common factor is 2. The second one, is there any 3 there? Yes, 3 is there in both. Actually it is twice common. Then we have one x here also. Then we have 3x minus 1 and we have 3x minus 1. Let us write down 2, 3, 3x and 3x minus 1. Let's multiply. 2 into 3 6, 6 into 3 18, x into 3x minus 1, which is the answer of this question. That's all for now. Until the next time, take care and bye.